Hi guys, today we will enter the chapter 2 differentiation, subtopic 2.1 derivative of the function.
So before we start our content, let us look at the learning outcomes. At the end of the lesson, students should be able to A. Relate the concept of derivative of a function to the gradient of a tangent. B. Find the derivative of a function using the first principle.
So let us look at the concept. So if you have the drawing this curve here and where we have a line touch the curve here, so this line we call it as a tangent, while we may also have a line which is perpendicular with the tangent, and this line we call it as a normal line. So the derivative of gradient function describe the gradient of a curve at any point on the curve. So if we want to find the derivative, meaning that we are finding the gradient of a curve. Similarly, it also describes the gradient of a tangent to a curve at any point on the curve. Next, the normal to a curve is the line which is perpendicular to the tangent to the curve at a given point. So that's why we will have this formula that we're going to relate the gradient of the tangent and gradient of normal, where gradient of tangent multiplied with gradient of normal is equal to -1. So after that, let's move on to the derivative of a function. Derivative of a function f with respect to x is denoted by the f prime x and is defined by the formula of f prime x equal to the limit of the fx plus h minus fx over h for h approaches 0. So this one will actually is a previous knowledge that we learned in chapter 1, the concept of a limit. Okay, so we will use the concept of limit to find the derivative of a function, where the limit is exists. If the limit exists, function is said to be differentiable with respect to x. The process of finding the f prime x is called differentiation. And the notation that is sometimes used is that if y equal to fx, so we can represent it, the differentiation as dy dx, or we can represent with the y prime, or we also can represent by the d over dx fx, or we also can represent by the f prime x. So we have a few notation to represent a differentiation. For example, the derivative for the y equal to x cubed can be written as d over dx x cubed, or we can also write as the dy dx. And this formula that we just now show you is f prime x, which is equal to the limit fx plus h minus fx over h for h approaches 0. We know it as differentiation using the first principle. Okay, let us look at the first example. Find from the first principle the differential coefficient of y with respect of x if a. y equal to 2x plus 3, b. y equal to x squared. Let's see the solution for both a and b. A, we are given the function fx equal to 2x plus 3. Right, this is a linear function definitely. So we're going to use the first principle of the differentiation formula, which is given by this one. So from there we could see that you need to determine the fx plus h and fx. But the fx is already given in the question. So the next thing we shall do is to find out the fx plus h. So to get the fx plus h, you just replace the input of x becoming the x plus h to the x. So that's why this one, you replace the x with x plus h. Then we just expand it as usual, and you get 2x plus 2h plus 3. So with that, now we can just put both of the value into our first principal formula, which we will obtain 2x plus 2h plus 3 minus 2x plus 3 over h. So the following is we may expand the negative in bracket. So you will get this 2x plus 2h plus 3 minus 2s minus 3, where you actually can cancel out both 2x minus 2x is 0, and the 3 minus 3 is also 0. Then we will remain 2h over h. So next we can cancel out the both h here, and you will get limit 2 for h approaches 0. By using the concept of limit of k x approaches a, which is equal to k. So limit of 2h approaches to 0, you will get 2. Okay, next we will move on to the question B. Fx equal to x squared, and this is a quadratic function. So the concept is still the same. We apply the formula here, but before that we need to determine the fx plus h. So for that you just replace the x with the x plus h, and you will get this one. So following we will expand out, where you will get the expansion is x squared plus 2hx plus h squared. So with both the answer, now you can substitute to your f prime x formula, where you will get this bunch of things here: x squared plus 2hx plus h squared minus x squared over h. Then as usual, we can do the cancellation, where the x squared by the x squared will be removed out, and it will remain 2hx plus h squared over h. Okay, next we're going to factorize the h up there. So both of them, they can take out h, where you will get h2x plus h over h. With that, we can finally cancel out the h both up and down, where you will remain it as the limit to s plus h for h approaches 0. So by substitute the h to the function as 0, so you will get 2s plus 0. So remember class, once you have already substitute the h as 0, the limit will be removed. Okay, the limit symbol will be removed. So you will get 2x. Next, you move to example 2. Find the derivative of y equal to 1 over x by using differentiation from the first principles. So the function that is given to us here is a reciprocal function. So the concept is still the same, like example 1. So let's take a look for the solution. So before we want to use the first principle formula, let us write the y in the form of fx. Okay, so fx equal to 1 over x, and from the formula we realize that we must get the both fx plus h and fx. Okay, so fx is already have, so now the next is we determine the fx plus h with the new input have already changed from the x become x plus h. So this x also will replace with x plus h. Okay, so let us substitute both fx and fx plus h. So we will get like this. Okay, so for this part here, before we proceed, we need to equalize the denominator first. So I just take out this part here. We do equalizing. So that we equalize this both of the fractions. So we will get cross multiply 1 times x, x minus 1 times x plus h. So x plus h, and divided by the denominator is x times x plus h. Okay, so Now we transfer this answer here, okay, back to the f prime x formula. That's why over here you will get like this. So this one is the part that I transferred in just now, okay. So that means here you can just expand the negative in. So this one you will get the equal to the limit h approaches 0, x minus h divided by x times x plus h. Okay, and where is the over h here? Okay, so actually the over h here we can just make it multiply. So when you multiply, the h will become 1 over h. Okay, so next we're going to simplify again, and we have x minus x will cancel each other, where you will get like this. So with that we can cancel the h, where you will get the limit h approaches 0, negative 1 over x times x plus h. Okay, so we already get the simplest form already. So next is we going to substitute the 0 to the h. Okay, so once we substitute, the limit h approaches 0 is already eliminate already. Okay, so you will get like negative 1 over x plus 0. So with that you simplify, then you will get an answer is negative 1 over x squared. So we move to the last question, example 3. Differentiate y equal to 2x squared minus 1 from first principles and find the slope of the curve at the point 1, 1. And for this question you have two parts. Okay, the first is to differentiate the function y using first principle, and secondly is to determine the slope, means the gradient at a given point 1, 1. So let us look at the solution. Okay, before that we change the y as fx first, which is 2x squared minus 1. And from the formula we know that we have to determine the fx plus h. So means that you have to change the input x become x plus h. So what I circle here, later we will going to replace by x plus h. Okay, which you will get fx plus h equal to 2 x plus h square minus 1. And next we expand the bracket here, where you will get 2 times x square plus 2hx plus h square minus 1. Then we expand it again, which you get 2x square plus 4hx plus 2h square minus 1. Next we're going to substitute both the fx plus h and fx that we have obtained to this formula. So that's why you will get like this. Limit h approaches 0, 2x square plus 4hx plus 2h square minus 1. Okay, and then you minus the fx here, 2x square minus 1 over h. So with that you can expand the negative inside the bracket there, where you will get negative 2x square plus 1. Okay, next for sure we have to cancel. So 2x square and 2x square will cancel, and minus 1 plus 1 also each other will cancel. Where you will simplify, you get the answer is 4hx plus 2h square over h. Definitely the limit h approaches 0 still there. Okay, next we're going to factorize out, okay, both the h here. So that's why you get the limit h approaches 0, h 4x plus 2h over h. So eventually the h will cancel, then you will get limit of h approaches 0 for x plus 2h. Okay, so this is the simplest form already. Now you can substitute the h as 0. So eventually you will get the f prime x equal to 4x plus 2 times 0, which is 4x. And then the second part of the question asking for the slope at the point 1, 1.
So by substitute the coordinate x equal to 1 to your function, so you get f prime 1 equal to 4 times 1, which is equal to 4. So that's all for this first lecture of the lesson. Thank you, class.